So if it's a flat mirror, what is the focal length of a flat mirror? Well, first off, what's the radius of a curvature of a flat mirror?
There isn't. So it's just straight.
Officially, what would it be?
0.
The other end,
360.
infinity.
Infinity.
Yeah.
So yeah, the second guess.
Because light coming in straight should go through the focal point and it should bounce straight back, and so, in theory, it's an infinite distance away. And so the focal length is infinite. So 1 over infinity is 1 over d object plus 1 over di. And what's 1 divided by infinity? What's 1 divided by a really huge number?
Yeah.
Not a really huge number.
Really small number.
Yeah.
Yeah, really small number. So this is basically 0, and so 1 over do is equal to negative 1 over di, or the object, or that's on how you want to write it. The image is the negative distance of the object. In other words, the image is virtual because it looks like it's coming behind. You stand in front of a mirror, you're not seeing an image that looks like it's right there in your face. It looks like it's behind the mirror. Matter of fact, it's looking like behind the mirror, the exact same distance you are from the mirror. Next time you're looking in the mirror, think about that. Think about the distance it takes from the mirror to you, and then think about what it appears as the distance from the mirror to the image.
It's kind of like looking through a window at yourself.
Yes.
Okay.
All right,
Now I see
so
what you're saying.
let's see if I can get lucky on the real image. Sorry, floating coin illusion. This is the one I want right here. I was hoping there'd be something more than just the still image here. Oh, no, it is YouTube. Yeah, this is going to be the most dynamic part of the video right here. I see it blinking.
It's doing something. Oh, it's solid now.
Very good.
Get this thing to stick. There we go. Ah, it's coming up. Oh, all right, this describes it and goes through the math of it. It doesn't actually show. Really? Everything that's on YouTube and they aren't gonna show this? Let's do it this way. Exploding.
Maybe floating coin mirror trick.
That's where we were before. Wow. This is,
Your niche.
oh, there we go.
Magician revealed.
All right, so coin in the bottom. And now, it looks like the coin's splitting on top. That's a real image. But the coin's in the very bottom of it. So that's what I'm talking about.
Oh. He needs to clean his mirrors.
It's two concave mirrors because of where the coin is. And I guess for the record, I guess we have the 3D Mirrorscope Illusion of Magic Illusion Revealed, and put out by Fahad Magician, January 12th, 2018. What else do you need for copyright? And potentially, if you zoom in, you could see the web address right there. All right, so it looks like in that case that the object is in front of the mirror itself. And sort of blinding myself. Questions before I kill the light?
So you said that was a real image? That would be
That's a real image.
real image.
Because it looks like, because the light is physically actually hitting at that spot. So, mirror equation we did, the magnification, spherical aberrations. All right. Well, that in essence is chapter 34 right there. All right. Let's make sure that you are up to snuff. You all have calculators as demonstrated earlier. So let's concave mirror. Focal point is 15 centimeters from center of mirror. Object is, let's say 20 centimeters in front. DI equals magnification equals.
centimeters. That's what I got for.
All right.
Yeah.
For DI?
For magnification.
Yeah, I'll accept that.
-3.
Yeah, that's what I was more thinking of. The magnification officially is 3, what does the negative sign mean?
It's inverted? It's inverted.
Inverted. If it were virtual, where would the negative be? Well, yeah, this would not be negative, but where would the negative sign be if it were virtual?
Oh, the focal point?
No.
The distance of the image?
Yeah,
DI?
that would be negative if, the negative focal point is if we had the convex mirror. So let's do that one. Let's now make this vex. Convex mirror, same focal point is still 15 centimeters from the center of the mirror. And the object is 20 centimeters in front on the mirrored side.
Do the same thing, just -60.
No.
Okay.
Because the first time around, it was 1/15 is equal to 1/20 plus 1/d sub I. Now it's -1/15 is 1/20 plus 1/d sub I.
Okay, so it's just the focal point that, or the F that will change to negative.
Yeah, as soon as I change the shape of the mirror, or which way it's curved. I assume, William, you have an answer at this one? You have that look.
Oh, God.
Wait, I'm not asking what the answer is, I'm just saying, do you have the answer?
I have an answer.
Okay, you have an answer, okay. Let's give everyone the chance here, and let's hear some new voices chiming in. Someone other than William or Curtis?
The distance, I got -8.57 inches. Magnification, I got 0.428.
Got what again?
0.428.
All right, units, what are the units are?
Distance is centimeters.
And magnification? Right. And that's the letter in there. For this point, I don't know how much is getting blocked by the mirror. So if, do one more of these. If concave with 15 centimeters, image is virtual. What is the range of DO? In other words, I have a concave mirror. I have some focal length right here. Where does the image need to be so that we have a virtual? So where does the object need to be so we have a virtual image? It's basically a range of things.
Behind the mirror.
Then it won't actually reflect. There'll be no image. This one obviously is a little bit tougher. Give you a chance to tackle it before I chime in.
Do we have DI? DI the same?
All image is virtual, so DI is going to be a negative number. So the question is, where is DO so that DI is negative? If you need to do specific points, if you make up some negative image distance in order to calculate for DO.
Kind of just plug and play until we get one. Is that what you're saying?
That is one technique.
That's probably not the best technique.
It'll take some time, but if you do a couple of them, maybe that will then you go, oh, wait a second, I'm noticing something common to all of these.
We're looking for a virtual image, correct?
Yeah, so the question is, where do I put the object so that I will get a virtual image? What are the, in essence, the extremes? It's also good for me to see the struggle here, because it's the kind of thing I'm going, well, we've done all the other kind of problems on the test. Let's just do something like this, just to spice it up a little bit.
So our magnification has to be positive for it to be virtual?
Yes.
Here's a term. I got at 10 centimeters, that would be virtual.
Okay. Anyone else have a different, something else, we can sort of piece it together? Anyone else doing the plug and chug method? All right. Why don't I sort of push this through considering the time? So 1 over the focal length is equal to 1 over the object distance plus 1 over the image distance. Let's see if we can, ultimately I'm trying to figure out DO so that the image here is negative. So I'm gonna actually solve for DI here. So what I'm gonna do is I'm gonna multiply everything, actually I'm gonna add these two fractions together. Sorry. 1 over D sub I would be 1 over D sub O minus 1 over F. Getting common denominator would be DOF, so this would be F minus DO. In other words, I multiply this by F over F, and I multiply this by DO over DO. So DI is going to be the flip of that, so DOF over F minus DO. I want my image to be negative because it's virtual. So the question is, when is this fraction negative? Did I get a slide backwards here? Something. Oh, there's. I'll keep that DO. When I subtract DO from both sides, that's the 1 over F is positive, that's negative. So. Sorry about that. All right, so when is this fraction going to be negative? All right, F, is F positive or negative?
Positive.
Yeah, it's concave mirror, so F is positive. The object distance, we have an object sitting in front of it. Is the object distance positive or negative?
Positive.
It's positive also. All right, I have this thing on the bottom here. What do you know about in order for this whole thing to be negative, what do you know about the denominator then?
Has to be negative.
It has to be, because the numerator is positive. So when is DO minus F equal to 0? Oh, sorry, I want it less than 0.
When the F is greater than DO.
Yep. So as long as, if I've got my convex mirror here, concave mirror here, if the object is anywhere in here, I'm going to get a virtual image. Which is why, since this is at 15 centimeters, why at 10 centimeters you got something, got a virtual image. Anyway, I believe that ended the lesson. And probably a bit long, I might do it for a lab or do it in class tomorrow, but we should be able to find the radius of curvature of this several different ways. And so I'm curious how close we can actually get. I don't officially know what the radius of curvature is, so it'll be an adventure.